See, like that wasn't on the video, but now my
No,
video like improved. Take that. So yesterday, you guys learned the exponential growth formula, which just so yeah, today's 3/28/23. So yesterday, you guys learned the growth formula, which you'll recall is A equals P times 1 plus R to the power of T. And remember, at first you looked at it and you're like, what's going on the TV? That looks really weird. And then we started using it and you realize like, hey, this isn't bad at all. So today we're going to switch the formula a little bit. So this formula is for what we call exponential growth. And as I alluded to yesterday, on the other side of things, there's also something called exponential decay. And so the word decay, it has like a real sort of like tooth decay negative sound, but it's just simply in math the term we use when something is going down. And that can mean the value of something in dollars. It can mean the population of a certain species. It can mean a lot of different things. Zoom. So again, the term decay can refer to a lot of different things. But what we're going to see today is problems where instead of something increasing in value, like your money in an account, we're going to see something decreasing, like say the value of a car. So let's just make up a hypothetical here. And let's say that you purchase a car for, I don't know, $34,000.
Doesn't it appreciate
Sure, and I like Brandon's number a lot. Like, so let's go with the fact that it depreciates. Let's go with 6% per year. I have no issues with that at all. In fact, I like that a lot. So let's say that it loses value, depreciates, whatever you want to call it. It goes down in value 6% per year. And again, I'm making this up. I have no idea what the actual number would be, but for the sake of a math problem, it'll do just fine. So the down arrow just signifies that it's losing value at a rate of 6% per year. So if I wanted to do this like I did it yesterday, I could walk you guys through the brutal process of doing year 1 and then year 2 and then year 3, but we're just going to jump right in today and save time. So what's going to happen now is same rule as yesterday. You're going to convert your rate into a decimal, and then you're just going to plug it into the formula. So let's say I wanted to know how much this car is worth after 5 years. So taking some notes and writing some things down, I think, should be the first step, and then we'll all plug it into our calculators. So this is what it's going to look like. So like the amount that the car is worth, that's like your final value, is going to be equal to the initial value of the car, and that's 34,000. But this time, notice I'm putting a minus in here. And so the 1 minus is going to cause us now to go under the full value of the car. So 1 minus, and what is 6% as a decimal? It's not 0.6. 0.06. Always move the decimal 2 places, and then our exponent's going to be 5, right? And so just like yesterday, you just simply type this into your calculator and let it do all the heavy lifting for you. So I did. Oh, someone had accidentally taken it. No, I think it was an accident. So we should all have 24,000. Good job. So you can see after 6 years, or after 5 years, that the car has depreciated by like a little over $9,000. Right?
Yeah.
For the record, the way you remember yesterday, I showed you what exponential growth looks like. If you do exponential growth, so just pay attention. This is from yesterday. Remember, exponential growth looks like this. Exponential decay is actually, interestingly, different than that. Exponential decay, the value of your car might start up here, and it actually loses most of its value early and then the curve starts to balance out. And if you think about it, so imagine you're driving like a 20-year-old jalopy. Like for real, that car at one point was new and it lost a lot of value in years 1, 2, 3, 4, 5, 6, 7, and 8. But would you agree that there comes a point where, like, if you've been driving a car for 20 years, isn't it worth about the same as it will be after 21 years?
No.
I mean, I know that there are exceptions to that, but like,
Especially if you like painting.
yeah, I mean, the point is, like, listen, the bottom line is if you bought an old pickup truck, let's say you bought a new pickup truck in the year 1994. Listen, by the time 30 years rolls around, if you're still fortunate enough to be driving that pickup truck, would we agree it's just about lost all the value it's going to lose? So like that's why the curve does that is it starts and it loses a lot of value for those first 10 years or so. But you see how my curve starts to flatten, and that's because there comes a point with exponential decay. It's like imagine your truck is now worth $2,800. I mean, what's 6% of $2,800? It's not a lot, right? It's not a lot. And so if you keep taking 6% of smaller and smaller numbers, the amount that it loses gets smaller and smaller until eventually the curve almost looks like it flattens out. It never really does, but it looks like it does.
Why do you use 6%?
Brandon just threw that out when he was standing over here. He just said 6%. So I don't know what the actual value of car depreciation is, but there's probably a website that would tell us. Yeah, I just threw that one out there. So does that make sense?
On the calculator, how do you?
You have to hit the little that caret. This thing, Brandon. It looks like that, Brandon. Yeah. So that's your up arrow. That's your exponent button.
Cool. Yeah, it's a little high. So if
You may not.
You're saying
No, not the vegetable carrot, Sam. God darn it. On keyboards, that little up arrow is referred to as a carrot. It doesn't look like an orange carrot like Bugs Bunny would eat. It's a different word. Wow. Need a sip of coffee after that little sidetrack there. So I want you to see also, last thing, and then I think I'm going to let you guys work, is that exponential decay does not, growth also does not have to be by the year. So let's say you have a population of bacteria. It's like 384,250 little bacteria somewhere. And someone has figured out like a solution that kills off the bacteria at a certain fixed percentage, right? So let's say that you have a little solution that will cause this to exponentially decrease at a rate of 13% per day. And again, I wanted to change this with you so you don't always think that T refers to years. Bless you. You'll be able to tell from the problem what T is. Is it minutes? Is it hours? Is it days? Is it weeks? Is it years? Is it months? You'll know just from reading the context of the problem. So my question then is, let's figure out how many bacteria would be left in this culture if we waited on this for 30 days.
So what did you have to time 13 by 30?
We're just going to follow the formula quite faithfully. Are you ready? So here we go. We're going to say the amount of bacteria left, and you guys just grabbing for your calculators. You're really missing a chance to get something in your notes here. Calculator will be next. So I'm going to say final amount of bacteria is equal to starting amount, so 384,250, and just follow the formulas, dudes. In parentheses, 1 minus 0.13 is the correct decimal version of 13%. And what am I going to raise it up to the power of? 30. So again, that's not years. It's the problem is written in terms of this happens each day, right? So that's why we would use days as our time. So this should be a very low population by the time 30 days has come and gone. So yeah, so you can see it in 30 days, and 13% doesn't feel like a lot to people. Like 13% is a little bit over a tenth. But if you keep hitting something like that back to back to back to back to back, again, a lot of loss happens in those first 10 or 15 days because you're taking 13% of a lot. And 13% of a lot is still a lot.
When we do the
right?
math, are they going to ask for
I don't remember. We can look at a couple real quick. So anyways, this population of bacteria after 30 days would be 5,891. I feel like in a problem like this, it would probably have you round to the nearest whole bacteria. So like in this case, I think I would just put 5891. But I mean, there's decimals like 0.03282989, whatever, but I don't think we need. So let me, while I'm still recording, let me pull up the delta and we can just kind of see what they look like. Just so you have a little idea going into it. So, okay, so like here's a problem. This is what your problems will look like here. We'll get going just in a few minutes. Stay with me here. So in this problem, I have 780 grams of some element and it decays, goes down at a rate of 17.1% per minute. How much of the element is remaining after 19 minutes? So again, the key is the setup. That's where you and your paper kind of have a little come to Jesus and say, okay, I got to get this lined out and then I'll type it in. So in this problem, I'm going to say, okay, final amount will be starting amount times 1 minus what?
17. Is it? Oh, it's 0.171.
It is 0.171.
Oh, yeah.
If you forget to move the decimal, you'll miss them every time, right?
Yeah.
And then we're going to raise that to the power of 19. Now notice it says round to the nearest tenth. And so if you're typing along with me, which you don't have to, but if you are, you'd get 22. So my calculator, in case you're not working along, says 22.1121353. So if it says nearest tenth, remember the tenths place is the first number after the decimal. So that means there will be no numbers after this blue wall. So will it be 20?
22.
Right. 10. For my answer will be 22.1. And I don't think I have to label it. How much? So I think I can just put 22.1. And if it makes me put grams, if it marks it wrong, that's because it wanted the grams. So, okay, so we're good. All right. And so here's one now that is growth. And this one says to round to the nearest penny. So that's going to be 2 decimal places, right? So you know it's growth because it's an annual interest rate and you're putting money in an account. So obviously this time we're going to use the plus formula and not the minus formula, right? So do you guys think you can handle a bunch of these? We can do this one together, sure. So like in this problem here, bless you, I'm going to say, okay, the amount of money I'll have is equal to the starting amount, what I placed into the account, 2,200. And then in parentheses, I'm going to put 1 plus
0.725.
point.
725. No, it's 0.25.
You have to move the decimal twice. There are no exceptions to that. If you move it once in this case and say 0.725, that's a 72.5% interest rate, which is going to really cause things to go haywire, right? And what am I going to raise this up to? Good. Bless you. So let's type this one in. So 2200 parentheses 1 plus 0.0725 to the power of 29. And I got 16747.28479. 28 cents. Very good. And remember, the rounding to the nearest cent means you'll round, stop at the blue bar. And so I look at the 4, and the 4 will not change the 8. And so I would leave it at 28 cents. Bless you. Any questions about that? And I don't even think you probably need dollar signs. I'll take one for the team here if it's wrong, but I think I can just type in 16,747.28 and just hit submit. Yeah, it doesn't need like dollar signs or time labels or anything like that. It just wants the numbers. You guys good to go? I think the assignment has it's already assigned. You might want to, anyone in Delta yet?
Yeah.
Is it there?
Yeah.
Okay. It's mixed, right? You won't get the same problems as your buddies. It's randomly assigned. You'll get some growth, some decay. You might get 5 growth in a row, 5 decay in a row. It's just computers gonna pick them. Who knows? And if anyone wants to go over one, I can go guardian your screen up here and go through it with you. I'm gonna pause the recording. Bryce, you had said you want to go over a question.
Yeah. So this is to the nearest phone number. I don't need it.
Correct. Right. So I'm recording this again if anyone's interested. So like Bryce has this question. So Bryce, I can see that yours is going to go down, right? Because it says decay. So you should have done 140 times 1 minus 0.216 raised to the power of 20.
Yeah, and that's what I did.
And your problem if it marked it is that you don't have it rounded to the nearest tenth. Tenth place is just 1 decimal place. You have it rounded to the nearest hundredth. So like, I don't know what the answer is, but I have a feeling based on what I see on your screen that you probably meant to put 1.1, right?
Yeah.
Okay, so remember, tenth is 1 decimal place, hundredths is 2, thousandths is 3, so on and so forth. Okay.